Hi guys, Mr. Scrayback here to help you with another practice problem. This time we are working on the problem in the predicting the properties of ionic and covalent compounds. And the question that we are being asked is, place the following substances in order of increasing boiling points. Okay, so the three substances we have here are NH3, H2 or hydrogen gas, and magnesium chloride. So NH3 or ammonia, hydrogen gas, and magnesium chloride. And we were given a list of 3 steps to use in order to help figure us out this problem. So step 1 is to determine if the compound is covalent or ionic. Now, how do we do that? If you can recall from the last 2 lessons, okay, in order to figure out if a compound is covalent or ionic, you need to know if it is made out of metals or nonmetals, or if it's a combination of metals and nonmetals. So let's take a look at NH3 first. So NH3. So first of all, remember that looking at nitrogen, it has 5 valence electrons. And because it has 5 valence electrons, it needs to gain electrons in order for it to become full, to have its outer shell full. So because it has to gain electrons, we consider it a nonmetal. Nonmetals are usually on this side of the periodic table. Okay? These would all be considered nonmetals because they have to gain electrons and they get that negative charge. Okay? And metals, okay, metals are things that have to lose those electrons to gain that positive charge. So metals are typically found from group 13. Remember, we're skipping this middle section. And then over here, okay, so these are all of our metals if you're looking at your periodic table. And if you go to the ptable.com, this exact same periodic table is available for you. Okay. Now, the only exception to that rule is hydrogen. Because hydrogen is so small, remember that it is also a nonmetal. So when we look at NH3, well, okay, NH3 has a nonmetal and a nonmetal bonded together, which we know based off of the periodic table, and we also know that because of the number of valence electrons it has. So because it's a nonmetal and a nonmetal, it is covalent. Okay, so that is a covalent compound. So that's the first thing I need to do, is I need to do that for all 3 of these. Okay, so let's take a look. So hydrogen, H2. Well, we were just talking about how hydrogen is considered a nonmetal. So again, we have a nonmetal and a nonmetal bonded together. Okay, 2 hydrogens, 2 nonmetals. So this would also be considered covalent. And then finally, we have MgCl2. So magnesium chloride. Well, magnesium, if we're looking on our periodic table, if we find magnesium, which is right here in group 2. Oh, it's in group 2, so it has 2 valence electrons. It's going to lose those, so therefore it's going to have a positive charge and be a metal. So it falls into that metal group. So this time we have a metal, okay, and then chlorine. Let's try and find chlorine. Chlorine is over here, group 17. Looks like it falls under that non-metal category. So this time we have a metal and a non-metal. And because we have a metal and a non-metal, this is considered ionic. Okay, so we have 2 covalent compounds and an ionic compound in this problem. All right, so that's the first step. So once you have those, the second step is to figure out, okay, of your compounds that are covalent, are they polar or non-polar covalent? because that's going to play a role. Remember in the presentation, in the lesson, we were talking about water and how water has such a high heat capacity. It's really hard to boil water or cool water down because it has all these extra bonds because of it being a polar molecule. So because it's polar, we know that it's going to have a slightly higher boiling point than something that would be a nonpolar molecule. So that's important to figure out. So when we look at NH3, the only way we can know if it's polar or nonpolar is if we draw the Lewis dot structure and figure out the distribution of electrons. So if I do a quick Lewis dot structure, so nitrogen, okay, so nitrogen's in group 15, so that means that nitrogen's going to have 5 valence electrons, okay, and we know hydrogen is in group 1, so it has 1 valence electron. And my formula is telling me that I have 3 of them, so I gotta draw 3 of these. Okay, so where are these gonna match up? Well, it looks like we're gonna have this, and a line here, and I'll draw a line here. Okay, so now I can kind of figure out this distribution of electrons. It looks like, and I can kind of clean this up too, okay, that it would look something like this if I wanted to kind of evenly distribute those, get a better look at it. So looking at this, okay, it looks like this hydrogen has 2 electrons because of this bond here. This hydrogen's got 2, this hydrogen's got 2, but this nitrogen's got 2, 4, 6, 7, 8. It has 8 electrons. So this one would be considered polar, because there's an uneven distribution of electrons between the nitrogens and the hydrogen. Okay? So this is a polar molecule. All right? Now for hydrogen, we got to do the same thing because this is covalent as well. All right? So hydrogen, we just did the Lewis dot structure up there. Pretty simple. It says I got 2 of them, so boom, done. There's hydrogen. Okay, hydrogen's got that one single bond between the two. Because remember, hydrogen's really small. It only needs those 2 electrons to fill its outer shell. So this hydrogen's got 2. This hydrogen's got 2. This is considered nonpolar. Okay, so this is nonpolar. And then for magnesium chloride, we don't have to do anything. We don't have to do anything because it's ionic. And if you're ionic, we don't have to worry about polar or nonpolar. So we're just going to kind of leave this one blank for right now. Okay? And the last step of this is to take a look and say, all right, so we've done step 1, we've done step 2. Now the next one is the boiling point, like ranking, if you will, is always that ionic compounds have the highest boiling points, which you saw in the video with salt and sugar, that the salt did not boil while the sugar did boil. So that means it takes a lot of energy to boil something that's ionically compounded together. Okay? Then it goes polar and then nonpolar. So if you are nonpolar covalent, you have the lowest boiling points. If you're polar covalent, you're kind of in that middle ground, medium, and then ionics have the highest. All right? So that would mean that if this is polar, this is going to be, I'll call it medium. I don't know the exact number, so I'm just going to say medium. Okay, I'm going to say low boiling point. And this is ionic, so this will be a high boiling point. So I'm asking you guys to do this in a CER format. And if you can remember from the CER format, right, you need your claim, evidence, and you're going to need at least 3 pieces of evidence. So I'm going to go ahead and put 1, 2, and 3 pieces of evidence there. And then you need to explain that evidence. Okay? So my claim, based off of this, I can simply say that my claim is that the following substances have their boiling points from least to greatest in the order of, and then I'll just put down my order of least being H2, the next being NH3, and then finally MgCl2. Sorry to get crammed up here, but okay. So that's my order, right? Is I'm going from least hydrogen, NH3, magnesium chloride. Okay, so that's my order. That's my claim. All right. The evidence would have to be from these two columns here. Are you ionic? Are you covalent? And are you polar or nonpolar? Okay, so evidence might be MgCl2 is ionic. I'm not going to say anything else. I just know it's ionic. I'm not going to say anything else about that in my evidence. That's just a fact. I'm not going to explain why that fact's important yet. That comes in reasoning. Okay. NH3 is going to be polar covalent. And you could even say is polar covalent as seen in the Lewis dot structure. Okay? And finally, H2 is non-polar covalent. And then I could also add in as seen in the Lewis dot structure. Now, this is important, the as seen in the Lewis dot structure, because it's not only accurate to say it's polar covalent. Okay, that's great. But where am I getting that information from? Well, I'm getting it from the Lewis dot structure that I made. So that's not only accurate, it's also specific, because I'm telling you where I'm getting that information from. And then lastly, in your reasoning, this is where you would explain all this information. So you can say ionic compounds have the highest boiling points, while covalents have lower boiling points. For my reasoning. Okay. And I could add on to this. I don't have enough room here, but I could say while covalents have lower boiling points based on whether they're polar or nonpolar. Okay. So that would be important for your reasoning. So I want you to try and do the CER problem that is in the presentation on your own. Okay, you may have to draw these Lewis dot structures. They don't have to be in your answers, but you probably are going to have to draw these out to figure out whether or not they're polar or non-polar covalent. Okay, and remember that ionics do not worry about polar versus non-polar. That doesn't matter when it's an ionic compound. Okay, so if you have any issues, please come see me during office hours on Tuesday. I'll be happy to help you guys out, and I hope you're helping each other stay happy, and hope you're staying healthy, and I hope to see you sooner rather than later. Bye, guys.